Today's meeting covers three topics, one on each page. No single one of these topics takes a huge amount of time, but they're each important to cover, and I believe with this content that will finish out what we want to test you on for this unit. So let's start. The first topic is called Interpreting Observations to Deduce Whether a Reaction is endo or exothermic. This was a topic I talked about in the last class meeting video, but I don't think it started until minute 4 or so. And so let me get a pen going here. I think students are pretty good with seeing this graph and knowing that it's exothermic, and seeing this graph and knowing that it's endothermic. So let me just write exothermic and endothermic on the side. Where students are getting thrown off is interpreting the observations, right, having this and deducing that it's exo, or having this and determining in deducing that it's endothermic. So let's work through the reasoning there. Really, it's a transfer between potential energy and kinetic energy of a system. So you experienced that in physics last year. The classic example is the cart at the top of the ramp. It starts with all potential energy and no kinetic energy. You let the cart go, the potential energy decreases and the kinetic energy increases. That's exactly what you have in this situation here. It's just that all you can see in the system is you can see the reading on the thermometer, which tells you that the molecules in the system are speeding up. So the kinetic energy of those particles in the system is increasing. And what made those particles in the system increase? The lowering of the chemical potential energy. So when you see that thermometer in that reaction vessel, when you see that temperature increase, you have to conclude that it's an exothermic reaction. And now think about it if you were holding that vessel. I'm going to do not a very good hand here. But if you were holding that reaction vessel, you'd be saying, wow, that's getting hot. So the fact that the temperature increases and the fact that your hand feels warm, those go side by side. Those are both observations that you would make and to conclude that the reaction was exothermic. Where is that energy coming from? It's coming from a lowering of the chemical potential energy. This lower one is just the flip of that. So what we have there is we have, again, students were good seeing the graph and saying, oh, that's endothermic. But now imagine yourself in the chemistry lab and you're feeling the flask of a reaction and it gets really cold. Well, what's happening there is this is a uphill reaction, so to speak. There's more stored energy in the products. Now, we're not tackling as yet why it's doing that, but that scenario exists in chemistry. So you're actually storing more energy, potential energy in the bonds of the products. So where does that energy come from? It comes from you, or it comes from the motion of the particles in the container. So the flask getting cold goes along with the temperature of the reaction vessel decreasing. Both of those are your indications that energy is being taken from the system and the surroundings in order to drive this uphill reaction. Okay, that's part 1. Part 2 is going to be a PhET simulation that you're going to do. So we'll have the link on the website. And this is perhaps fits a little bit better with last unit on chemical reactions because there's nothing really energy that we're talking about here. And what drives this is that sometimes when you put your reactants in the reactant vessel, and now this is a PhET simulation you're going to play with, but there are reactants in this reaction vessel here. And sometimes you have leftovers. You have more of one of the reactants than you needed to make the reaction proceed. And so what's being shown here is they give us a chemical equation. So we see that for every 2 hydrogen molecules and 1 oxygen molecule, that gives us exactly the right number of atoms to make 2 water molecules. So what the student does in responding to this is the student circles 2 hydrogen molecules and 1 oxygen gas molecule. That's circling the ingredients that are in this chemical reaction, and so therefore that's going to produce 2 water molecules. That's why 2 water molecules have been drawn here. The atoms that I enclosed here, the 4 hydrogen atoms and 2 oxygen atoms, make these products, the 4 hydrogen atoms and the 2 oxygen atoms, which makes, I guess I'll change pen color, which makes this remaining oxygen molecule a leftover. So again, this has nothing to do with energy, but it's something that's going to be included in this unit test. And so what you would do is, as it appears on the bottom here, so you would be given something like this with a blank box here. So you take in your test, it says that you've got 2 hydrogen molecules and an oxygen molecule that makes water, and you have to see what happens with these ingredients. So you enclose 2 hydrogen molecules and an oxygen molecule. And with that, you need to draw 2 water. Notice that you have to draw 2 water. So now I'm just going to keep this a 1 color pen, but let's see how I do. I draw a water molecule. This may not come out great, and I draw a second water molecule. Okay. So now I've drawn the 2 water molecules that come from the 2 hydrogen molecules and the 1 oxygen molecule. But I have a leftover. What's my leftover? My leftover is this hydrogen molecule, so I also have to include that over here. And that would be a correct answer to that problem. So this is the topic of leftovers. Again, arguably it's better suited to last unit than this current one on energy, but it is what it is. So we're going to include those questions as well. I see I'm at 7 minutes, so I'm going to stop this video here and do a part 2.